Question number 4. Solve the following right triangle, which means that I'm going to look for all the missing angles and sides. Here I'm given C, which is the hypotenuse, and this angle alpha right there. So I just need to find beta, A, and B. There are different routes to solve that triangle, and I'm not going to take necessarily the quickest one to showcase as much as I can all the possibilities and processes. So I'm first going to try to find the side length A, which is with regard to alpha, which is the only one I know, the opposite. And I've got C, which is the hypotenuse. So what I'm going to do with regard to alpha, opposite, and hypotenuse, so katoa, I'm going to use the sign. So sine of alpha will be equal to A over C. And that means, because I'm looking for A, that A is equal to C times sine of alpha. And C is 10, and alpha is 36.8699 degrees. So I need to make sure that my mode is in degree. By default, it will be in radian. So make sure that you know how to have the degree mode. So I press enter, and now I'm going to type that expression, 10 times sine of 36.8699, and I've got 6.000 and so on. Now it says for length to the nearest integer, so it's going to be 6. Once I have that, I could very well use to find the missing side B to use the Pythagorean theorem. So, which states that A squared plus B squared equals C squared, the hypotenuse. And I want to find B, so I'm going to solve for B. The addition of A squared is going to become onto the other side a subtraction. And finally, I'm going to cross over that square. The inverse is square root. And I have this. Now, usually, whenever I cross over an exponent which is even, I would need to add a plus or minus here. But because I'm dealing with lengths, distances, it is not necessary because it can only be positive. And I will have, therefore, for B, square root of 10 square, the square of the hypotenuse, minus 6 square, the leg that I found. And if I press square root of 10 square minus 6 square, I've got 8. Finally, I'm going to go for B, for beta. Now, here, since I've got alpha, I could very well subtract the 36.8699 from 90, and that will give me the value. Let's do it here. Beta is 90 minus the other acute angle, and 90 minus 36.8699, I will have 53.1301 degrees. But I'm going to show you another way to find it using inverse trigonometric functions, operations. So what I'm going to do here, let me clear things up a little bit. Here we go. So the way I'm going to do, I'm going to use A and B, which are with regard to beta, the opposite and the adjacent. So what I'm going to do here, I'm going to set up the trigonometric ratio. I've got sine of beta, which will be equal, tangent, sorry, TOA, tangent of beta, which would be equal to the opposite b over the adjacent, which means that beta would be equal to the tangent inverse of b over a, which is the tangent inverse of b is, I found it is 8, and a was is 6. This is what I found. So 8 over 6, which is also 4 over 3. So I'm going to press second tangent to get the tangent inverse, 8 over 6, and I've got the exact same one. Here I want the 4 decimal to round it up. But as you can see, I get the exact same result, 53.1301 degree.